Most people sleep at night when it's dark and go to school or work during the day when it's light. We take day and night for granted because there hasn't been a time in our lives when night and day hasn't existed. But what exactly causes day and night? And what causes the amount of daylight and darkness to vary throughout the year? If you live in a northern area, such as Canada or the northern United States, you're very aware that the weather in July is quite different than the weather in January. Even if you live in a southern place, such as Florida, you still notice an overall change in weather throughout the year. What forces are responsible for these changes? During the next few minutes, we're going to answer these questions and others as we explore Earth's rotation and revolution. When watching a sunrise, is the sun moving or is the Earth moving relative to the sun? This is not an easy question to answer. In fact, for thousands of years, people thought the sun and other planets in our solar system moved around the Earth. It wasn't until the 1500s that a Polish astronomer named Nicholas Copernicus developed the idea that Earth and the other planets in our solar system actually revolved around the sun. Revolve means to travel in an orbit around the sun. An orbit is the path a planet takes around the sun. But how does Earth's orbit explain why the sun appears to travel across the sky from morning to evening? This is not related to Earth revolving around the sun, but rather has to do with the way the Earth spins or rotates. Notice how this coin appears to be spinning around a central point. Earth, too, spins around a central point, called an axis. Rotation is the process of Earth spinning on its axis. Let's see how the rotation of Earth causes day and night. Stand still for a moment. Do you feel Earth spinning? Of course you don't, but depending on your location on Earth, you could be rotating as fast as 1,600 kilometers per hour. That's faster than a jet plane. We can't feel ourselves spinning because the planet on which we stand is so massive. But we can see the result of Earth spinning when the sun rises and sets. Earth rotates around an imaginary line called an axis, which goes through Earth from the North Pole to the South Pole. Earth makes a complete rotation on its axis every 23 hours and 56 minutes, which we commonly round up to 24 hours. You decide. What do we call one 24-hour rotation? We refer to one 24-hour rotation as a day. We just described how Earth is always rotating on its axis. At the same time, Earth is also revolving around the sun. In fact, Earth is moving through space around the sun at the remarkable speed of 109,000 kilometers per hour. Even at this high speed, it still takes Earth a year, or more precisely 365.25 days, to make a complete revolution around the sun. Notice that 365 is not an even number. There's 25 1/100ths of a day extra for every revolution of Earth. Over 4 years, this adds up to 1 extra day. Therefore, every 4 years, we add on the extra day to the end of February, as February 29th. When this extra day is added, we call it a leap year. So every 4th year has 366 days and not the usual 365. A season is a term used to describe a certain time of the year. New England, for example, is a place with 4 distinct seasons. Winter is a time of cold weather, snow, and limited daylight. In spring, as the days grow warmer, the snow melts, grass grows, and flowers bloom. The amount of daylight increases. In the summer season, the daylight is long and the days are warm. And in the fall, the weather cools, daylight shortens, and leaves turn brilliant colors before falling to the ground. What's responsible for the changing seasons? As we mentioned earlier, Earth is not positioned with the poles straight up and down, but rather is tilted on its axis at an angle of 23.5 degrees. As Earth revolves around the Sun, its axis always points at the same angle, but the direction it points relative to the Sun changes. Throughout the course of the year, different parts of Earth are angled more toward the Sun than at other times of the year. Therefore, different parts of Earth receive varying amounts of light and heat throughout the year. North America receives less daylight due to the fact that the axis is pointed away from the Sun. The winter season begins. As Earth revolves, the axis begins to point more toward the Sun, as seen here in March, and the spring season begins. As Earth continues to revolve, the axis points more toward the Sun. In June, the north end of Earth's axis is tilted toward the Sun. North America receives a lot of daylight and experiences the summer season. As summer progresses, the days get shorter as the axis begins to point away from the Sun. This is the position of Earth in late September. You decide. What season follows? That's right. The fall season will take place over the next several months as the days shorten and grow cooler in North America. On December 21st and 22nd, this town in Vermont only experiences about 9 hours of daylight and over 15 hours of darkness. In the Northern Hemisphere, December 21st or 22nd is referred to as the winter solstice. The shortest day of the year in terms of daylight occurs on the winter solstice. On June 20th or 21st in the Northern Hemisphere is the summer solstice, the longest day of the year. Between the two solstices are 2 equinoxes. An equinox occurs when the Sun is directly over the equator. During an equinox, the hours of daylight and darkness are equal everywhere on Earth. In the Northern Hemisphere, on March 20th or 21st, is the vernal equinox. On the vernal equinox, there are 12 hours of daylight and 12 hours of darkness. You predict. When do you think the other equinox occurs? That's right. It occurs halfway between the summer solstice and the winter solstice. The autumnal equinox occurs on September 22nd or 23rd, which marks the beginning of the fall season. During the past few minutes, we've explored the fascinating topic of Earth's rotation and revolution. We discussed how Earth revolves around the Sun in an orbit, and that a single complete revolution takes 365.25 days. We then explored how Earth rotates on its axis every 24 hours, giving us day and night. And we discussed how the tilt of Earth on its axis at an angle of 23.5 degrees accounts for the different seasons. In summer, the northern hemisphere is tilted more toward the Sun, providing long, warm days. whereas in winter months, the northern hemisphere is tilted away from the sun, giving rise to shorter days and cooler temperatures. Last, we discussed that the winter solstice is the shortest day of the year in the northern hemisphere, and the summer solstice is the longest day of the year. The equinoxes occur halfway between the two solstices, when there are equal periods of darkness and daylight. So, the next time you admire a sunset or notice the change in seasons, think about some of the things we've discussed during the past few minutes. You just might think about Earth's rotation and revolution a little differently. Fill in the correct word to complete the sentence. Good luck, and let's get started. Number 1. Earth around the sun. Number 2. Day and night are the result of Earth's. Number 3. Seasons are the result of Earth toward or away from the sun. Number 4. In summer, North America is tilted the sun. Number 5. In North America, the solstice is the shortest day of the year.